So, Pythagorean theorem is how we find the distance between 2 points. So we're going to use a find the distance formula. We're actually going to derive it together. So what I want you guys to do is look at that picture. I know it's kind of small, but in the box. If I give you a point, or 2 points, A and B, so here's point A, here's point B, and I want you to find the distance between those 2 points, you could make a right triangle with any 2 points, correct? On the coordinate plane. So you can make a right triangle out of any 2 points on the coordinate plane and do the Pythagorean theorem to find the hypotenuse, which is the distance. So that you don't have to graph it every time, we derived the distance formula so that you could find the distance between any 2 points without having to graph it each time. For finding the distance formula, we have to be able to make the formula using unknowns so that you could plug in any points you want. So a coordinate always has x comma y, correct? Okay, so for point A, because we have to make general notations, we call it x1 comma y1. Is everybody okay with that? We did this for slope formula as well. So what would be the coordinates of B? x2, y2. And that just means the second x coordinate and the second y coordinate. Okay? So x2, y2. So in order to do the Pythagorean theorem, we need to find the length of both legs. So on the x-coordinate, or x-axis, how do I find the length of the x's, or the distance between them? What do you do to find distance between two things? Subtract. So to find the distance between the x-coordinates, let me move this. It got in the way. We subtract. So to find the distance between the x-coordinates, we subtract x2 minus x1. You guys did this already, right? With the number line and the absolute value. How do you find the distance between the y-coordinates? Subtract. This should make sense. To find the distance between two y values, you subtract. To find the distance between the two x values, you subtract. That gives you your legs. So then to find D, we just plug it into the Pythagorean theorem. Okay? So to find the distance between these 2 points, we plug in d squared equals, the length of one leg is x2 minus x1. So x2 minus x1, squared, plus, what's the length of the other leg? This one right here. y2 minus y1. So y2 minus y1 squared. Now, for distance, we want to do exactly what we did in that previous diagonal one. We want to get just d by itself. So how do I undo the square? Square root. So we square root both sides. And for you guys, I'm just going to have you erase that d squared and just write it as d. And that's your distance formula. Okay? So you use the Pythagorean theorem. You subtract the x's and square it. Subtract the y's and square it. Add them and take the square root. That's your distance. So let's do number 7 together. And I'll have you guys do number 8. We'll have time. I'll have you guys do number 8. So number 7. What is the distance between U and V? And I give you the coordinates, round to the nearest tenth. Here's how you're going to show your work. D equals Square root. Big old square root. We subtract the x's first. It doesn't matter which order you do them in. So I'm just going to do -7 minus 4. Because we end up squaring them, they're going to be the same no matter what. Plus, same thing with the y's. 5 minus -3 squared. Simplify. -7 minus 4 gives me -11 squared plus. One thing that I see a lot that you guys do, arithmetic error, subtracting a negative does what? Adds them. So 5 minus -3 actually is 8 squared. Okay. So D equals square root. -11 squared is 121. Plus 8 squared, which is 64. So D equals the square root of 185. And this is distance, so we want it in a decimal form. So, and the instructions say round to the nearest tenth. So distance is going to be, here, let's just actually rewrite it. D equals, it comes out to 13.6. That's your distance. Okay, so let's talk about the midpoint. So on a number line, there's two ways we can do the midpoint. On a number line, the midpoint is the coordinate or the average. Sorry, the coordinate of the midpoint is the average, or another word for average is mean, of the coordinates of the endpoints. So, for example, in the diagram, the coordinates are lowercase a and lowercase b. How do I find the average of those? Add them together and then divide by 2. That's all you're going to do for those types of problems. So let's look at number 1 in your examples. I'm looking at segment AB, so the one that's given to us. It has endpoints at -4 and in between 8 and 10, so at 9. So I'm just going to write 9 underneath it for myself. What is the coordinate of the midpoint? So to find the midpoint, we find the average. So -4 plus 9, and we'll divide by 2. Guys, what's -4 plus 9? No, you do not do absolute value because we're looking at coordinates. So sometimes it might be a negative number. So what's -4 plus 9? 5 divided by 2. And you can leave it as 5 over 2, or we can also put it as 2.5. Either one. So let's label it on the number line. So 2.5, that's 3, so 2.5 would be right in the middle. And let's label it M. Okay? So the midpoint is at 2.5. And that's a coordinate. It's not a distance. Okay, so I want you guys to make sure you're aware of that. It is a coordinate, not a distance. Okay, so then what about on the coordinate plane? So the coordinates of the midpoint, if we're looking at a segment that's on the coordinate plane, is the average of the x-coordinates and the average of the y-coordinates. So just like in when we were talking about the distance formula, the x-coordinate of your first point is going to be x1, and the x-coordinate of your second point is going to be x2. So when I'm finding the coordinate of the midpoint, to find the x-coordinate, we add x1 and x2 and divide by 2, comma. To find the coordinate, the y-coordinate of the midpoint, we do the same thing with the y's. y1 plus y2, divide by 2. And then close the parentheses. So this is finding an x comma y. So we're looking at average x comma average y, basically, is what we're looking for. Okay, and we're going to do number 3. Okay, you guys ready? So number 3, segment EF, and I already drew the segment for you. Segment EF has coordinates at E 7, 5 and F 2, negative 4, and I want to know what is the coordinate of M. So we would write capital M, comma, or not comma, parentheses. To find the x-coordinate of the midpoint, I take the average of the x-coordinates. So the x-coordinates are 7 and 2. So our first point is going to be 7 plus 2 divided by 2, comma. That's the x's. What about the y's? How do I find the y midpoint? 5 plus negative 4 divide by 2. Close the big parentheses. So my midpoint is at 7 plus 2 is 9. So at the point 9 over 2. And 5 plus negative 4 is 1 over 2. So we're at the point 9 over 2 and 1/2. You could also write this, 9 over 2 is 4.5. But I really think 1/2, you could leave it as 1. So 4.5 would be 1, 2, 3, 4.5, up 1/2. So it would be right here. That's your midpoint. Okay, questions or concerns about the midpoint? Okay, one last thing. I will also sometimes give you an endpoint and the midpoint, and you have to find the other endpoint. So turn the page, and we're going to do number 5. So number 5, I tell you that the midpoint of segment CD is M, negative 2, 1. So I'm going to graph that. So negative 2, 1 is right here, and that's my midpoint, M. Or actually, it's going to go this way, so M. And then I tell you that the endpoint C is at negative 5, 7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So here is C. and I want to find the endpoints of D. So we know the midpoint formula, and we know what the midpoint is. My midpoint, so let me just write this. M is x1 plus x2 over 2, comma, y1 plus y2 over 2. So in this case, I know the answer. The answer is -2, +1. Do I know what x1 is? Yeah, it's -5, but I don't know what x2 is, so we leave it as x2 over 2, comma. Do I know what y1 is? What is it? 7. So 7 plus y2 over 2. So we have two things we have to solve for the x's. So I'm going to do the x's down here. -2 equals -5 plus x2 divided by 2. And then you do the same thing for the y's. 1 equals, so there's that. 1 equals 7 plus y2 over 2. To solve, we multiply both sides by 2 to start, because that undoes the divide by 2. Wait for a second. So -4 equals -5 plus x2. Add 5, and you get x2 equals 1. You do the same thing for the y's, and you should get that y2 comes out to -5. So the point D would be at 1, -5. And then you could graph it.